Also 11.3, particle motion from an equation level 1. It says a particle moves along the x-axis, so at time greater than or equal to 0, its position is given by this function. Determine the velocity of the particle at t equals 1. So we talked about how x of t is a position. So where is it at on the number line over time? We want to find velocity. And remember, it goes x of t, and then we go v of t, and then we go acceleration. It's like it levels up. So this is just your original function, your derivative, and your second derivative. So I want to find v of t, which is really x prime of t. That would be 3t squared plus 10t minus 32. And then I'm literally saying, what is the velocity at a time of 1? And so I would just plug a 1 in. That would be 1 squared times 3 is 3 plus 10 minus 32. And that would be negative 19. And since that velocity is negative, you could think about it's moving to the left. Part B, determine the acceleration of the particle at a time of 3. So now we want to find a of t, which is actually the second derivative of our t function. And so I would go back to having this, and then taking the derivative of your velocity, which would be 6t plus 10. It gets easier every time we derive because we lose variables, and then we're wanting to find out at a time of 3. So it'd be 6 times 3 plus 10. That would be 28. So we are accelerating. Number 2, a particle moves along the x-axis so that time greater than or equal to 0, its position is given by this function. Determine all values of t when the particle is at rest. I know that happens when v of t is 0. So again, I would want to find the velocity function. That would be 3t squared minus 6t minus 45. Plug in. So I want to actually set this equal to 0 because I want to replace my velocity and make it 0 and solve for the t, the time. Solving this, fastest way would be just factoring. It looks like my GCF would be a 3, so I'd divide everything by 3. That'd be a t squared minus 2t minus 15. Factor that again. I need two numbers that multiply to make negative 15 that add to make negative 2, and that would be negative 5 and positive 3. Remember, you don't solve any numbers you factor out only if they have a variable with them, so that's nothing. So it'd be a time of 5 and a time of negative 3. But this set our times are only greater than or equal to 0, meaning we're only going to have our graph here in the first quadrant. So that answer is out. So it would only be t is 5. Determine the speed of the particle at time of 2. And speed is just the absolute value of velocity. So really we're just finding velocity again, and then if it's a negative, we're going to make it positive. That's what we saw on our graph, that even though we're going down into the negatives, that actually means we're speeding up because our velocity is increasing. It just tells us we're moving to the left. And so I would take my v of t function and plug in my time of 2. And I'm just going to do that all on a calculator real quick. And I get that the velocity is negative 45, but I want to take the absolute value of that, so my speed is simply 45. Part C, determine if the particle is moving to the left or the right at time of 1. So I would want to figure out if velocity is positive or negative. So I'm going to use my velocity function again, plug in 1. That'd be 3 minus 6 minus 45. 3 minus 6 is negative 3, minus 45 is negative 48. Since I get a negative, that means that I'm moving to the left. And part D, determine if the particle is speeding up or slowing down at t equals 2. And remember that speeding up or slowing down is based off of, do velocity and acceleration have same signs or different signs? If they have the same signs, then it's increasing or speeding up. If they have different signs, then it's slowing down. So we need to do velocity at a time of 2, figure out what sign that is. So that would be back to our velocity function, our 3 times 2 squared minus 6 times 2 minus 45. And we actually already did that right here. And we know that was negative 45 for velocity. So now I need to find acceleration. I don't think we've done any acceleration yet. So I'm going to find the derivative of my velocity function, which is right here. That would be 6t minus 6. And plug in that same time of 2. And I'm already seeing that I'm going to end up with a positive. So because this is positive and this is negative, that means they have different signs and I am slowing down. And that's it.